some new strategy to solve the validity paradox in any way. So I want to defend that this is possible to have non-structural and naive solutions to the validity paradox. That's one goal. As a case study, I will introduce a version of LP, in particular, it will be a copy version of LP, a validity copy version of LP. Because the trick will be to, in order to theory that is both naive and that retains every structural principle. One way to split apart the notions of evaluation satisfying an inference, and evaluation being a counterexample to that inference, meaning that there might be, so the idea is to present a framework that allows for evaluation neither to satisfy nor being a counterexample to a given inference, or to both satisfy and being a counterexample to a given inference. That will have as a result that in some of these logics, some inference will turn out to be both valid and invalid, and in others, there will be inference that will be neither valid nor invalid. This is what will happen with this particular version of LP I will be introducing. But my point is to present a general strategy, not to focus so much on this particular version of LP and the validity theory based on it. So I will start by introducing the validity paradox, which is the one that started this new literature on semantic paradoxes, and explaining what I understand for a naive validity theory, what I understand for a theory to be, or a logic to be non-substructural. Then I will introduce some technicalities, and then I will present the particular validity theory I will be defending or presenting, and then I will take some. So let's start with an introduction. So what's special about the validity paradox? It's a kind of semantic paradox, but most semantic paradox allows for operational solutions, meaning that you can block the unpleasant result by changing the classical meaning of some logical constant. But in this seminal paper, Bill and Mercy present this new version of this paradox that is sort of a version of the Curry paradox that seems to demand either giving up some structural principle or giving up some of the two principles that they claim that characterize a validity predicate as naive. Okay. And non-structural approaches, in particular, most of the more well-known no-classical solutions to semantic paradox are non-substructural, seem to have no choice but to give up some principle of naive validity. But then these non-substructural approaches cannot be the base of a theory of naive validity, properly speaking, because they need to give up some of these principles of naive validity. So I want to present here what seems like an integral position that it's possible to have properly non-substructural solutions to the validity paradox that retain both naive validity principles. In particular, but this means I explain a little bit more what I mean by this, but as a consequence, in the particular theory I will be introducing this principle of naive validity, VG, validity detachment, won't be valid, but it won't be valid either. Will not be valid. And this justifies not having the problematic instance of PD as an axiom in a possible sequence calculus for this field. So what I mean by naive and by theory being non-substructural in this context. Well, this is my official definition of a theory, of a validity theory being naive. It is naive if and only if it either validates these two principles that characterize a principle, validity theory as naive, VP and VT, according to Mercy. So either a validity theory is naive if and only if either it validates both of them, or just not invalidate them, or validate one and just not invalidate the other. And similarly, a theory is non-substructural if and only if it validates every structural principle, every principle that does not require explicit mention of a logical constant, or just not invalidate them, or validate some of them and just not invalidate the others. So, of course, how reasonable are these definitions? Given the traditional way to understand validity as an invalidity as an exhaustive and exclusive pair, meaning that every inference is either valid or invalid, and no inference is both valid and invalid at the same time, then these definitions are cumbersome and unnecessarily long because the free disjuncts in each definition says exactly the same thing. Okay, but also according to this same traditional position, it is not incorrect. Okay, so yes, it's cumbersome and unnecessarily long, but it should not present a problem for this traditional approach to validity and invalidity. So now what is semantic validity paradox? The choice is a version of the validity paradox that involves a validity predicate governed by these two principles. VP is validity proof and VD is validity attachment, can be understood as principles governing the introduction of a validity predicate on the right and on the left in a sequence calculus for it. Validity proof says can be understood as saying that if an inference is valid, then you can assert that it is valid. A validity attachment can be understood as saying that if a validity assertion claiming that the inference from A to B is valid holds and also holds A, then B also holds. Okay. And Mercy showed that if we have a validity, a sequence calculus without validity predicate governed by these rules, and also have cut and contraction, weakening, then you get to be a trivial system. So in order to prove that, we need a self-referential procedure, of course. So in particular, we need a sentence phi that needs to be equivalent to the validity assertion from phi to falsum. So intuitively it says that the inference from phi to falsum is valid. And with those elements, you can show that falsum is the right. So you start on the left with an instance of VD with phi replacing formula A and falsum replacing formula B. Then, well, the validity assertion is equivalent to pi, so you substitute it. Then you contract on the left, and on the right you have the same inference up to that point. Then you apply validity proof and obtain the validity assertion on the right, but this is equivalent to pi, so you substitute this for pi, and then you cut on pi and you obtain pi. Of course, falsum can be any formula, and if you also have weakening, then you can write every inference. So this seems undesirable. This paradox has been employed for substructural logicians in the semantic paradox field to argue that to be of cut or contraction is the best or the only solution, possible solution to this problem. And moreover, this seems to have some virtues, particularly Ripley defend that substructural solutions to semantic paradox provide the only uniform solution to every semantic paradox, because Ripley claims that every semantic paradox involves applying cut at some point. So you can solve every semantic paradox in the same way by giving a cut. And Miller-Mercy claim that it's the only way to have a significant talk about validity, because the validity predicate is characterized by these two principles, PP and VT. So no theory can be a genuine theory of validity if I give up PP or VT. So that's the end of the introduction. So I will be working with a propositional language with some additions. Later on, I will be using this validity predicate. First, I will start developing the logic side, and then I will introduce the validity predicate. And also, we need a set of names for sets of formulas. And well, I will use these two notions. Of course, an inference is another pair of formulas, and a meta-inference is probably less known. By a meta-inference, I mean another pair of set of inferences. Okay, so with the subsequent one, this means that gamma and delta are sets of inferences. Okay, weakening and cut, for instance, are cases of meta-inferences. So, and in the framework I will introduce, three families of logics can be defined. First, logics defined through gaps between the satisfaction conditions and the counterexample conditions, meaning that there will be valuations available that neither satisfy nor are counterexample to formulas or inferences. Then logics are characterized through gluts in the satisfaction and counterexample conditions, meaning that there will be valuations both satisfy and are counterexample to some inference. And finally, logics that has both validity gaps and gluts. But here I will just focus as a case study on the first family of logics. And I will just present, and indeed the paper that I have wrote, I have just explored these strong linear logics that can be defined with this setting. So this is the strong linear algebra that I assume is well known. And so what's new is here. So the logic I will be introducing, the logics I explore in the article, are named, I gave them this schematic name. Here the XY specify the satisfaction conditions, what it takes for the evaluation to satisfy an inference. And WZ specify the countersample conditions, what it takes for evaluation to be a countersample to a given inference. So, and XY, W and Z are standards. And by standards, I mean just sets of truth values. Okay? So I'm defining the logics semantically. So as the framework is free value, they are just free values. I will be working with. So for instance, LP is characterized, the satisfaction condition that define the logical P has the set 1 and 1/2 as both x and y, and the logic K3 has the singleton of 1 replacing x and y first. And evaluation satisfies an inference in this, according to this logic, if and only if you just need to focus on the x, y here. So just in case, if every premise gets a value in x, remember that x are sets of truth values, then some conclusion should get a value in y. Okay, that means evaluation satisfies an inference in this set. If every evaluation satisfies the inference, then the inference is valid. This is pretty straightforward. Pretty standard. What's new is the next item. The W set establish when evaluation is a counterexample to a particular inference. And in order for evaluation to be a counterexample to this inference, according to this logic, you just need to focus on what's happening here and what are the values here. What's the set replacing W, what's the set replacing set. So evaluation is a counterexample to an inference according to this logic, if and only if the evaluation gives a value in W to every premise and a value in set to every conclusion. If that happens, then the evaluation is a counterexample to that inference, and an inference is invalid and only if it has a counterexample. Okay. So that establishes what are the satisfaction and counterexample conditions for inferences. But I also need to talk about PP and CAT and weakening, and those things are meta inferences. So what does it mean that a meta inference is valid in this semantic perspective? Well, there are two main options: the local and the global approach. According to the local approach, meta inference. Remember, there is an inference between inference, so to speak. According to the local approach, meta inference is valid if and only if every evaluation that satisfies every premise also satisfies some conclusion. According to the global approach, meta inference is valid just in case if every premise is valid, then the conclusion is valid. Okay. But what does it mean here for a evaluation to be a counterexample to a meta inference, and what does it mean for a meta inference to be invalid? Well, evaluation is a counterexample to a meta inference. This should have the subscript 1, meaning that this is a set of inference and this is a particular inference. In a logic this type, if and only if every premise is satisfied by evaluation according to the standard of satisfaction as y, then the evaluation is a counterexample to the delta, but according to the standard for counterexamples, which is W set. Okay. A meta inference is locally invalid, just in case it has a counterexample, meaning again that satisfies every premise according to x, y, and is also counterexample to the conclusion according to W set. And it's globally valid if and only if every premise is x, y valid and the conclusion is W set invalid. So the standards I will be using in this talk are just these ones. Right? S and T are again standard in this literature on semantic paradoxes, substructural solutions to semantic paradoxes. S is for the strict standard, that is a singleton of 1. T is the set that has 1 and 1/2. And then I will be also talking about the complement of T, that is a singleton of 0. Okay. So, and this is the particular logic I will be focusing on, which is a copy version of LP. It has TT as a standard for satisfaction, and S complement of T as standard for counterexample. So it is a version of LP because the standard of validity, the standard of satisfaction is TT, which is a standard for, which is a way to, which is how LP works in this mixed setting, in this mixed strong Pliny setting. So evaluation satisfy an inference according to this logic and according to LP, just in case if every premise gets value 1 or 1/2, at least one conclusion gets value 1 or 1/2. And this is valid and only every evaluation satisfies. But in LP, in the traditional LP, evaluation is a counterexample to an inference if and only if every premise gets value 1 or 1/2, and every conclusion gets value 0. In this copy version of the P, in order for evaluation to be a counterexample to an inference, it has to give value 1 to every premise and value 0 to every conclusion, instead of allowing premises to have value 1. So it's more demanding. In order for evaluation to be a counterexample to an inference, the conditions that the evaluation has to meet are more demanding than in the standard counterexample relation of every. And this logic is gappy regarding valuations, meaning that there are valuations that neither satisfy nor are counterexample to some inferences, in particular, for instance, small exponents. There will be evaluations that neither satisfy nor are counterexample to some instances of small exponents. So if this gets value 1/2, and this gets value 0, then this gets value 1. Okay, so so this valuation does not satisfy this inference because it goes from every premise gets a designated value 1/2, but the conclusion does not get a designated value. But it's not a counterexample because it's not the case that every premise gets value 1; it gets value 1/2. So this makes this valuation neither this valuation neither satisfies nor is a counterexample to this. Okay. Cut weakening and contraction will be that are the meta inference that are involved in the derivation of the problematic results are valid both locally and globally, because in order to find out whether they are valid or invalid, you just need to check whether they are valid or invalid according to the satisfaction standard, which is TT, which is the standard satisfaction of the P, and LP is fully structured. And that's important on this slide. And this logic can be the base of validity theory. So you can use this in order to define validity theory that is naive and both non-substructural. So in order to do that, well, you need to add validity predicates to the logic and determine how the validity assertion gets a truth value. Okay. And then you also need to answer the question of what do the axiom appearance of a summit of the sequent calculus for the here correspond to. We will talk about that later on. Regarding the first thing that needs to be taken care of. So how the truth value of the validity assertions are fixed. So it is possible to interpret the validity break as a conditional, as an extensional conditional. I have explored that way in the paper, but the more mainstream option is to design a fixed point interpretation for the validity predicate. And it is possible to develop this fixed point interpretation. The one that I have defined in the paper is based on an old Toby Meadows paper that gives a fixed point interpretation of the validity predicate. And the key of this, this is that a formula does not receive a truth value in a model or interpretation, but in a model and a fixed point. The Toby Meadows is very different to Toby Meadows theory is very different to the one that we have presented here, because it's deeply non-substructural, it's non-reflexive and non-transitive. But this is based on Kripke's fixed point contraction for the truth value. But in this fixed point proposal, the programmatic instance of PD involved with the derivation of the validity paradox so you need to start from a set with an initial extension for the validity predicate, and a set for an initial and extension of the validity predicate, you extend it through a jump operator, and the relevant instance of BD with the Bill-Murphy sentence will start outside of both the extension and the extension and remain outside both sets all along. And as it stays outside these two sets, we will receive value 1. So these slides are a bunch of definitions that just says that the first says that a formula gets a value, what I've just said, that a formula gets a value not just in a model or evaluation, but in a model and a fixed point. And in this theory, it's a formula is satisfied can only if it gets value 1.5. And the rest of the slides are really of things that I said. Of course, pretty straightforward. And what I want to stress in this slide is just that the relevant fixed point I will be using is the minimal fixed point. So, in order to determine whether what truth value a formula received, in particular what truth value a validity assertion received, you need to focus on the minimal fixed point, not on other fixed points. I think nothing essential depends on this, but it's just a pretty standard option that, of course, has this justification, at least in the case of the truth predicate. But I will not be talking about that here. So in this, and this is important, this validity theory based on this version or copy version of LP, these two things hold. The first thing is that says that BP holds. And it holds in every significant possible way, meaning that it's locally valid, globally invalid, and it's also not locally invalid, not globally invalid. And but also holds this second thing that says that BD with the second principle that characterizes validity predicate as naive. It says that it's not the case that BD is invalid. Okay? It won't be valid because there will be operations that don't satisfy. There will be instances of BD that are not valid. In particular, the instance of BD with pi, the Wilmer's sentence and falsum here is such that these two things value will have. This is value 0, of course. And it gets value 1/2. These two formula gets value 1/2, and this gets value 0 in every evaluation, every model. So actually no valuation satisfies the inference, but no valuation is a counterexample to it. So so these copy non-substructural solutions, the one that I have presented, but also many others that can be defined, treat validity assertion as neither valid nor invalid. The validity assertion appears in the validity paradox, the Bill-Murphy sentence. So the paradox can be blocked because the relevant instance. So from the semantic side, the relevant instance of PD is not invalid. That is what justifies the theory based on it. What makes the theory based on it as a theory of naive validity. But from the proof theoretic side, the paradox can be blocked because the relevant instance of PD is not valid. So you have you are justified in not having that instance of PD as an axiom of your proof system, because having that instance of PD as an axiom will mean sacrificing soundness, because you will be deriving not valid things. So this one I have already mentioned. Why this is a theory of naive validity? PD is not valid. Well, it's naive because it's not invalid. So it's a sort of naive in a negative way because naive principles are not invalid. And the intuitive principle that's in behind this answer says that an axiom of a small sigma calculus for a theory should be valid. It's not enough for it not to be invalid. And well, seems forceful because links proves to derivation from valid axioms. So this is not in these two slides are not in the paper, but just I put them to see what you think about it. So one possible interpretation of truth gaps and truth value gluts, at least according to Belknap's paper, is that they represent informational states of a computer regarding a particular sentence, meaning that truth value gaps represent absence of information about the whether or not a particular sentence is true, and truth value gluts represent contradictory information about it. Well, validity gaps and gluts might represent informational state of a computer regarding a particular way to process that information. Validity gaps might be representing the absence of information about whether a particular rule of inference should be incorporated or forbidden. And validity gluts might represent contradictory information about whether a particular rule of inference should be accepted or forbidden. Probably validity gluts are more hard to swallow than validity gaps. So it's true that it's problematic what you do with them, but I guess that it's not more problematic than in particularly no other specific way that truth gluts are problematic. And that acting on contradictory information of the truth. A second possible answer about what you do when facing a validity glut is to embrace a dialectic theory about acceptance and rejection, meaning that you should both accept and reject that inference, but this is a less orthodox position. In fact, even Priest himself rejected, so it's not very popular. So, to conclude, I have introduced this family of non-structural and naive validity theories, and focus on one particular gappy version of LP, validity gappy version of LP, meaning that there will be inference, there are inferences in this logic that are, so in this validity theory that are both, that are neither valid nor invalid, not invalid. And probably something that I need to develop is a suitable proof system for these theories, and probably should be hybrid in the sense that they should have things representing valid stuff, things representing not invalid stuff, and also probably principles that govern the interaction between them. So that's it. Thank you.